Preparing for AI, ML at Kyndryl interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you explain the difference between artificial intelligence, machine learning, deep learning, and generative AI? Artificial intelligence is the broad goal of making machines perform tasks requiring human-like judgment. Machine learning achieves that through data-driven pattern learning, while deep learning uses multi-layer neural networks. Generative AI creates new text, images, code, or other content from learned distributions. For example, an enterprise may use machine learning to predict equipment failure and generative AI to summarize maintenance records. I would also emphasize governance, because capability without security, explainability, and human oversight creates operational risk. While answering, define each term clearly, explain their relationship, distinguish predictive from generative systems, and connect examples to enterprise use cases such as automation, forecasting, document processing, and conversational assistance. Question 2. How would you approach an AI, ML project for a Kyndryl enterprise client? I begin with the client's business problem rather than choosing a model first. I clarify users, constraints, expected value, risks, and measurable outcomes. Next, I assess data quality, privacy, ownership, integration points, and operational readiness. I would deliver a small, governed pilot with a baseline and business metrics, then validate it with users. If results justify scaling, I establish MLOps, monitoring, support ownership, and a phased deployment plan across the client's hybrid environment. Make sure to cover business objectives, stakeholder discovery, data readiness, security, architecture, measurable success criteria, pilot design, integration with existing systems, change management, and a roadmap from proof of concept to production. Question 3. What is overfitting and how would you detect and prevent it? Overfitting occurs when a model memorizes training data instead of learning patterns that generalize. I detect it when training performance is strong but validation or test performance is substantially worse. Prevention includes stronger validation, cross-validation where appropriate, regularization, simpler features, early stopping, dropout for neural networks, and more representative data. I keep the test set untouched until final evaluation. For enterprise deployments, I also test on time-based or client-specific splits to expose realistic drift. In your answer, explain training versus generalization error, validation behavior, cross-validation, regularization, early stopping, feature reduction, data augmentation, and why business performance must be checked on unseen production-like data. Question 4. How do you handle missing data and poor data quality in a machine learning project? I first profile missingness by feature, time period, source, and business segment. Missing values may be random, systematic, or meaningful, so I avoid blindly filling everything with a mean. Depending on context, I use robust imputation, explicit missing indicators, or exclude unreliable fields. I investigate outliers and duplicates with domain experts, prevent target leakage, and record transformations in versioned pipelines. Before deployment, automated quality checks should block or quarantine data that violates agreed thresholds. Be sure to mention profiling, missingness mechanisms, domain consultation, imputation choices, outlier detection, duplicate removal, leakage prevention, data lineage, validation rules, and documenting assumptions for auditability and repeatable production pipelines. Question 5. What is the difference between precision, recall, F1 score, and ROC-AUC? Precision measures how many predicted positives are truly positive, while recall measures how many actual positives we successfully identify. F1 balances both through their harmonic mean. ROC-AUC summarizes ranking quality across thresholds, but can appear optimistic with severe class imbalance. I choose metrics based on consequences. Fraud screening may prioritize recall, whereas expensive manual reviews may prioritize precision. I also report a confusion matrix, threshold-specific results, and business costs rather than presenting one score alone. While answering, define each metric mathematically in plain language, explain false positives and false negatives, discuss class imbalance, describe threshold selection, and relate metric choice to the client's operational and financial consequences. Question 6. How would you design a predictive maintenance model for industrial equipment? I would collect time-stamped sensor readings, maintenance logs, operating conditions, and failure events. The target must specify a prediction horizon, such as failure within 7 days, and features should summarize recent trends, volatility, and operating cycles. I would split data chronologically to avoid future leakage and address rare failures with suitable weighting or sampling. The model is useful only if alerts reach technicians with enough lead time, so I would measure avoided downtime, precision per asset, and alert workload. In your answer, cover sensor ingestion, event labeling, time windows, feature engineering, failure prediction horizons, class imbalance, alert fatigue, time-based validation, integration with maintenance workflows, and monitoring after deployment. Question 7. What is MLOps, and why is it important for enterprise AI deployments? MLOps applies software engineering and operations discipline to the full machine learning lifecycle. I use versioned data, code, features, and models, reproducible training, automated validation, a model registry, and controlled promotion between environments. After release, monitoring tracks service health, data drift, prediction quality, bias, and cost. Pipelines should support rollback and retraining triggers. This matters especially in managed enterprise environments, where ownership, auditability, security, and reliable support are as important as model accuracy. Make sure to cover reproducibility, data and model versioning, automated testing, CI/CD, deployment strategies, monitoring, rollback, governance, security, model registries, and collaboration between data scientists, engineers, and operations teams. Question 8. How would you monitor a machine learning model in production? I monitor 3 layers. Infrastructure metrics include latency, throughput, errors, resource usage, and availability. Data monitoring checks schema changes, missing values, distributions, and feature drift. Model monitoring tracks prediction distributions, calibration, fairness, and performance once labels arrive. Business metrics show whether decisions improve outcomes. I define thresholds, alert ownership, investigation playbooks, and rollback criteria before launch. Retraining should follow evidence and controlled validation, not an automatic response to every distribution change. Be sure to mention infrastructure metrics, data quality, feature drift, prediction drift, concept drift, delayed labels, fairness, business outcomes, alert thresholds, dashboards, incident response, and retraining decisions. Question 9. Explain data drift, concept drift, and model drift with examples. Data drift means the input distribution changes, such as customer behavior shifting after a new product launch. Concept drift means the relationship between inputs and the target changes, perhaps because fraud tactics evolve. Model drift is the resulting degradation in predictive performance. I detect these through statistical tests, distribution dashboards, delayed label evaluation, and segment analysis. Remediation might involve recalibration, new features, retraining, or a revised objective. I would always investigate the operational cause before changing the model. In your answer, distinguish changes in input distributions, relationships between inputs and targets, and overall predictive performance. Include detection techniques, business examples, and appropriate remediation actions. Question 10. How would you evaluate a large language model application for an enterprise client? I create a representative evaluation set from real tasks, with expert-written references and difficult edge cases. I measure answer relevance, factuality, groundedness, completeness, refusal behavior, toxicity, latency, and cost. For retrieval applications, I separately evaluate retrieval recall and generation quality. I include adversarial prompts, sensitive data tests, and human review for ambiguous cases. Before production, I establish acceptance thresholds and feedback workflows, because a model that sounds fluent but invents facts is unacceptable for enterprise decisions. While answering, cover task-specific quality, factuality, groundedness, safety, latency, cost, privacy, human review, representative test sets, adversarial testing, and production feedback loops rather than relying on generic benchmark scores. Question 11. What is retrieval-augmented generation, and when would you use it instead of fine-tuning? Retrieval-augmented generation retrieves relevant, authorized documents and supplies them to a language model before generation. A typical pipeline chunks documents, creates embeddings, searches a vector index, re-ranks results, and asks the model to answer with citations. I prefer RAG when knowledge changes frequently or must remain traceable. Fine-tuning is more appropriate for consistent behavior, formatting, or specialized language, not simply storing private facts. RAG still requires access controls, document quality checks, and hallucination evaluation. Make sure to explain document ingestion, chunking, embeddings, vector search, re-ranking, grounded generation, citations, freshness, access control, and the trade-off between retrieval augmentation and model fine-tuning. Question 12. How would you protect sensitive enterprise data in an AI/ML solution? I classify data first and minimize what the model can access. Sensitive fields should be masked, tokenized, or excluded unless necessary. I enforce identity-based authorization at ingestion, retrieval, training, and inference, with encryption in transit and at rest, private connectivity, tenant isolation, retention policies, and audit logging. Secrets never belong in prompts or source code. I also verify provider terms, disable unauthorized data reuse, test prompt injection paths, and design human escalation for high-impact decisions. Be sure to mention data classification, minimization, encryption, identity-based access, masking, tenant isolation, private networking, retention controls, audit logs, secrets management, and preventing confidential data from entering unauthorized models. Question 13. What responsible AI principles would you apply to a client-facing machine learning system? I apply responsible AI throughout design, not as a final checklist. That means defining intended use, affected groups, risks, and decision authority, checking data representativeness and disparate outcomes, protecting privacy, and documenting limitations. Explanations should be useful to the actual user, not merely technically available. High-impact decisions need human review, appeal paths, and clear accountability. I continue monitoring after deployment because fairness and safety can change with data, policies, and operating conditions. In your answer, address fairness, transparency, explainability, privacy, safety, accountability, human oversight, accessibility, impact assessment, documentation, and continuous monitoring throughout the system lifecycle. Question 14. How would you choose between a traditional machine learning model and a deep learning model? I start with the problem, data type, constraints, and baseline rather than assuming deep learning is superior. For tabular enterprise data with limited samples, gradient-boosted trees may deliver strong accuracy, speed, and interpretability. Deep learning becomes attractive for images, audio, language, or very large datasets, especially with transfer learning. I compare models using the same validation design and operational metrics. The best solution balances accuracy with latency, explainability, cost, maintainability, and governance. While answering, compare data volume, modality, interpretability, training cost, latency, feature engineering, transfer learning, maintenance, and business requirements. Emphasize establishing a simple baseline before increasing complexity. Question 15. How would you deploy an ML model across hybrid cloud and on-premises environments? I determine placement from data residency, latency, connectivity, hardware, compliance, and cost requirements. I package the model and dependencies in a tested container, expose a stable inference contract, and use environment-specific configuration rather than code changes. CD promotes signed artifacts through controlled stages, while orchestration handles scaling and health checks. I secure communication with mutual authentication, centralize observability, and test failover. Hybrid architecture should preserve a consistent operating model without forcing sensitive data unnecessarily into public cloud. Make sure to cover workload placement, data residency, containerization, API contracts, Kubernetes or equivalent orchestration, connectivity, identity, observability, latency, disaster recovery, and consistent model promotion across environments. Question 16. How would you reduce latency and cost for a production inference service? I profile the complete path first, separating network, preprocessing, model, retrieval, and post-processing time. Then I consider caching repeated results, batching compatible requests, reducing unnecessary tokens, using a smaller model, quantization, distillation, or specialized hardware. Autoscaling and asynchronous processing help absorb variable demand, while rate limits protect the service. Every optimization requires regression tests and cost-quality measurements. I would not sacrifice factuality or safety merely to achieve a lower latency number. In your answer, mention profiling, batching, caching, quantization, pruning, distillation, smaller models, autoscaling, hardware selection, asynchronous processing, token limits, and measuring quality impact before optimization. Question 17. What is data leakage, and how can it invalidate an ML evaluation? Data leakage occurs when information unavailable at prediction time influences training or evaluation. Examples include using a post-outcome field, randomly splitting time-dependent records, or fitting an imputer and scaler on the full dataset before splitting. Leakage produces impressive validation scores that collapse in production. I prevent it by defining prediction time availability, splitting before learned preprocessing, using chronological or entity-based splits, and keeping a truly untouched test set. I also review feature lineage with domain experts. Be sure to define leakage, provide temporal and preprocessing examples, explain why it inflates validation results, and describe pipeline isolation, feature availability checks, chronological splitting, and independent test data. Question 18. How would you explain a model's prediction to a non-technical business stakeholder? I begin with the decision the model supports and describe its output in business terms. For an individual prediction, I explain the strongest contributing factors, confidence, and what information was considered, while clearly stating that correlation is not causation. For overall behavior, I use feature importance and representative examples. I avoid technical jargon and show where the model can fail. A good explanation helps a stakeholder challenge an outcome, take action, and understand when human judgment must override it. In your answer, tailor the explanation to the decision, distinguish global from individual explanations, use plain language, discuss uncertainty and limitations, avoid implying causality, and connect explanations to actionable controls. Question 19. Describe a practical approach to deploying an AI chatbot for IT service management. I would ground the chatbot in approved service documentation and connect it to ticketing APIs through narrowly scoped tools. Authentication determines which knowledge and actions each user may access. The assistant should answer confidently only when retrieval quality and policy checks pass. Otherwise, it asks clarifying questions or escalates to an agent. I would test common incidents, ambiguous requests, prompt injection, and data exposure. Success metrics include first contact resolution, escalation accuracy, satisfaction, latency, and reduced handling time. While answering, cover intent discovery, knowledge grounding, ticket integration, authentication, confidence thresholds, escalation, prompt injection defense, conversation logging, evaluation, and metrics such as resolution rate and user satisfaction. Question 20. How do you communicate an AI, ML project's risks, progress, and value to clients and senior stakeholders? I use a concise narrative: the business problem, baseline, proposed intervention, evidence, risks, and next decision. I separate model metrics from business outcomes and explain assumptions, dependencies, and uncertainty plainly. A dashboard can show quality, adoption, cost, latency, incidents, and value indicators, while a risk register tracks privacy, security, bias, and operational concerns. I recommend explicit stage gates for pilot, production, and scale. Credibility comes from reporting weaknesses early, not overselling a promising demo. Make sure to cover business outcomes, transparent assumptions, model and operational metrics, risk register, dependencies, decision gates, plain language reporting, realistic timelines, and recommendations tied to measurable client priorities. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.